Okay, so the first thing we have to apply F equals ma, right? Okay, first we had to mark all the forces. So we did with that. We are done. So then we can apply F equals ma for each of these masses. So first to the A, using F equals ma to A. So I apply downward. So in downward we have 50 Newton. The weight is acting downward. 50 minus the tension is upward T1 equals mass is 5 times A. So this is equation 1. And then I can use F equals ma to uh, C, using F equals ma to C. So that one we had to apply in vertical upward direction. So then we have T2 minus 20 equals mass is 2 into A. So this is equation number 2. So if you compare this equation 1 and 2, you have 1, 2, 3 variables, 3 unknown variables. Then we have only 2 equations. Therefore, you should get another equation. Otherwise, the system is unsolvable. Okay. So in order to find get another equation, we can apply F equals ma for B, right? So using F equals ma to B. Okay. So that one we can apply in this side because it is accelerating this direction. So therefore T1 minus T2 equals mass is 10 into A. Okay. So then we have this as equation number 3. Okay. So then now we can use these 3 equations to solve and find the values of A, B and C. Okay. So first I can add these 2 equations. So I get T2 minus T1. If I add these 2 equations, I get T2 minus T1. Therefore here I multiply this equation by minus, so then I get T2 minus T1 equals minus 10. Okay, I take this as equation number 3. Okay, so then I add equation number 1 and 2. So if I add these 2 in the left hand side, I have T2 minus T1. Here T2 minus T1 and 50 minus 20 is plus 30. So we simplify the left hand side. In the right hand side, 5a plus 2a is equals to 7a. So here T2 minus T1 is equals to minus 10a. So from equation 3, we can write minus 10a plus 30 is equals to 7a. So therefore, a equals to. So if you take this 10a to the other side, it becomes 17a. So therefore, 30 divided by 17 meters per second squared. So that is the acceleration. So then in the first question, we need to give the acceleration of A, B and C. Therefore, acceleration of A is acceleration of A is downward, 30 over 17 meters per second square. And then acceleration of B is up, B is into the left, no? So B is in this direction, the same acceleration, 30 over 17 meters per second squared. And then acceleration of C is upward, 30 over 17 meters per second squared. Okay. So I did this question just to revise what we discussed in the last week. Okay. And then you can substitute the value of A in equation 1 to find the value of T1 and in equation 2 to find the value of T2. Okay. Okay. I hope you all already got the answers before I'm getting the value of A. Okay. And if anyone's still writing, you can take a screenshot and the remain finding the T1 and T2 you can do later. Okay. After the class or maybe tomorrow. But you should do, you must do. Okay. Right. So I'll erase this. And I'll give you another homework. Here, I'll change this smooth table as a friction, rough. So here rough, and I'll give you the new S and new K values. New S, the static friction coefficient. So here 50 Newton, this 10, 100 into 0.2. New S is 0.2 and new K is 0.1. Okay. And then you had to do this question. You had to find the acceleration of A, B, and C and find the tension in both strings. So by considering this as a rough, the table is rough and new S is 0.2, new K is 0.1. That is, I assigned you as a homework. Okay. So each and everyone should do it and send me before the next class. I mean on Thursday. We have our next class on Thursday, right? So before the next class, each of you have to do it and send me. It's a must. And at the beginning of the class, I will discuss that question, and then probably in the next class we are starting momentum, linear momentum. Okay. So today in this class, we will be discussing more questions on inclined planes, which we started in the next class. Sorry, in the last week. Okay. Yeah. So let's move on and let's do a question from inclined plane. Okay. So once again, I will tell you here all the mass values are same 5 kilogram, 10 kilogram and 2 kilogram. Only the difference is instead of a smooth table, you have a rough table where nu s is 0.2, nu k is 0.1. And then you have to find the acceleration of A, B and C and find the tension in both strings. Okay, right. Okay, so let's start the inclined planes. Yeah, sure. Take a screenshot, guys. Okay. Okay, you're welcome. Right. So, Okay, so here we have a inclined plane making angle 30 with the horizontal. So the first question, Q1, the table is smooth. We consider the first question as the plane is smooth, and the mass of this, let's consider 5 kilogram, and this one is let's take as 3 kilogram. Okay. So the question number 1. So question number 1, draw all the forces acting on 3 kilogram and 5 kilogram. And question number 2, find their accelerations. And question number 3, find the tension of the string. Okay. So I'll give you a couple of minutes. Once again, I remind you the previous homework which I assigned you, you must do it and send it to me before Thursday's class, before commencing of the Thursday's class. No, before the Thursday's class starting at 9, no, you should send me before Thursday 5 p.m. Okay. And make sure to draw the diagrams neatly. I will check everything, okay, marking the forces and all. Okay, so the marking the forces and all easy, so I'll do that part, and you have to find the acceleration and the tension of the string. So here this one 30 Newton and this is 50 Newton. So that string and all the normal usual conditions like light, inextensible, uh, pulley is smooth. Okay, and also consider this plane is fixed. Okay, fixed with the ground. Okay, fixed to the ground. That means it can't move. Okay, but suppose if this is not fixed to the ground and the ground is smooth, then what happens? Due to this motion, there will be a motion of this as well. So those kind of things we don't do in physics class because it will be little bit difficult. We have to deal with relative acceleration. But for those who are doing combined maths, you guys have a separate lesson to deal with those kind of questions, relative acceleration in applied. Okay, but in physics we don't discuss those. We consider the inclined plane is fixed. Okay, here the tension, I can mark T. So here the tension will be T, and here the tension will be T. It's T. Okay, so now we want to uh, find the acceleration. First, we have to realize which one will move, whether this 3 kilogram will move up or move down or remain stationary. So that one will depends on this mass values. So here the mass is high, so the weight is 50 Newton. Okay, so and then we can resolve this into two perpendicular directions, the weight. So one in this direction and this one is in this direction. And let's mark the normal reaction force. That will be from here. So this normal reaction force. And then this is 50 cos 30. Because this angle will be 30 degrees and this will be 50 sine 30. Okay. Okay, so here, if we consider 50 sine 30, 50 sine 30 is equals to 50 into sine 30 is half. So therefore, it is equals to 25 newtons. Okay, 25 newtons. That means if you consider this object, so along the plane, this component 50 sine 30 pulls this with 25 Newton, but this one pulling downwards with 30 Newton. So which is the higher weight? This one. So therefore, it will move downward. So this one will move downwards. So let's mark the acceleration A, and this one will move upward. A acceleration. Okay. Okay. So the next thing is you need to apply F equals MA to both 5 kilogram and 3 kilogram to find the acceleration. Okay. So first I can write for the 3 kilogram. So using F equals MA to 3 kilogram. By the way, anyone has got the acceleration value? Anyone got the acceleration by now? Hirosh, did you got the expression? And Abhushan? No. Okay. So we can use if equals ma to using if equals ma to 3 kilogram. Okay, to 3 kilogram. So I'm applying downward. So in downward, the weight is 30 Newton minus tension T equals, I just write the value, the units I'll put later. 30 minus T equals mass is 3 into acceleration A. So this is equation number 1. And then I can apply using, okay, I got an answer from student 508 in test person. Okay, let's check. So I can apply F equals ma to the 5 kilogram using F equals ma to 5 kilogram. So that one I'm applying in this direction parallel to the plane. Okay, so the angle here is 30. So in that direction we have 50 sine 30 minus the tension T equals mass is 5 kilogram into acceleration A. So 50 sine 30 is 25 minus T equals 5A. So this will be equation number 2. So then I can add equation 1 and 2. So add 1 plus 2. Hold on. I use this for downward. Sorry, here. This one I had to apply upward direction. Okay. Because acceleration is in this direction, right? So in this direction, making angle 30. So therefore it will be T minus 50 sine 30 is 25 is equals to mass is 5 into A. This is equation number 2. Now I can take 1 plus 2. So the left hand side minus T and plus T cancel. 30 minus 25 is 5. So 5 equals 3A plus 5A, 8A. So therefore A equals 5 over 8 meters per second squared. Okay. Okay, so that is the acceleration. And then we want to find the tension. So we can substitute in the equation number 2. From 2, I have T is equals to 5 into 5 over 8 plus 25. So T equals 25 divided by 8 will be 25 divided by 8 will be, so 24 divided by 8 is 30. Sorry, 24 divided by 8 is 3 and remaining 1, that remainder 1 divided by 8 will be 1 divided by 4 is 0.25, therefore 0.125 plus 25. So therefore T equals 28.125 newtons. Okay, did I got the tension correct? Abhishek, you got the same answer? Okay, so did you all understand? Atika, Zufar? Okay. Okay, so now I'm going to modify this question. I'm going to modify this question as taking, yeah, you can take a screenshot and then complete this. Okay, so now I'm going to modify this question and giving as question number 2. So that modification is I take this plane is rough. Now friction is there, rough, and then I take new S static friction coefficient as um, so, mm, okay. So new S I take 0.1 and this one I change to the mass of this I change to 0.1 gram. Okay. So then the other things are okay. So only that the change I did, that the plane is rough. I change the mass of this 2.1 grams and this is 5 kilogram and nu s is 0.1. Nu k is equals to, because we want to find the acceleration. So acceleration means when it's moving, right? So when it's moving, you should have the friction will be kinetic friction. Therefore, I should give the nu k also. So nu k I give 0.05. Okay. Uh, we don't have to use MUS, right? It's not clear. MUS, what does it mean? MU. Hmm. Mu, you mean this one, mu. Okay. Yeah, so here this is rough now. So now when you are doing the finding the acceleration, now you have the friction, no? So to find the friction, you need to know these values, right? Otherwise, you can't find the friction, no? To find acceleration, now to find acceleration, how do we find? You have to apply F equals ma for this, and also you have to apply F equals ma for this. When you're applying F equals ma for this, the friction also come there, no? Then to find the friction, you need these values. Now when it's accelerating means you should know should need this value, no? Kinetic friction coefficient. Yeah, to find the acceleration only mu k is enough, but I give mu s because first you have to identify whether it will accelerate or not, right? Suppose the net force, now the net force acting on this mass is actually this 50 sine 30 minus the tension. So if this value is less than fs, then it won't accelerate, no, right? So in order to accelerate, this value should be greater than fs. So the first thing you have to get an idea about what is the value of fs. So fs is equals to maximum friction force equal nu s times r. So fs equals nu s is 0.1 into r will be equals to, now if you consider the equilibrium in this direction, r equals 50 cos 30, right? Considering the vertical equilibrium, so r equals 50 cos 30. So therefore it is cos 30 is root 3 over 2. So 50 into root 3 over 2. So 25 root 3, right? So this is in 0.1 into 25 root 3. So root 3 is 1.7. So this is something like 25, around 35, 40. So Fs is equals to 0.1 into 40, let's say 4 newtons. But this one is we have nearly here, here this value is 50 sine 30 is 25. If you assume the system is in equilibrium, the tension maximum value is T equals mg. Mass is 0.1 gram. Okay, so here gram means then it's very small mass. Okay, so here is the 0.1 gram. So you have to write in kilogram. So 0.0001 because you had to divide by 1000. No? 1, 2, 3. Yeah. Shall we? This value is very small. Shall we change this? Shall we change to 0.1 kilogram? So 0.1. So 1 Newton. 1 and 4 Newton. And resultant is something. Yeah. Let's make it. Let's change this to 1 Newton. Okay. 0.1 Newton. Sorry, 0.1 kilogram. Make it this 0.1 kilogram. Okay. Okay, so I gave you a rough idea about how to do this question. So you can carry on. I'll start the explanation in 2 minutes. You have to find the acceleration of 0.1 kilogram and the 5 kilogram. And the next one, the tension in the string. Those are 2 things you need to find. Okay, here first we need to, uh, but apparently I can see this object will accelerate downwards. Okay, this one will accelerate upward. Okay, because here the new s is 0.1. Okay, this is 0.1. Therefore, the maximum friction Fs is equals to 0.1 into R, which is 50 cos 30. 50 cos 30 means 50 into 30 root 3 over 2. Okay, so it is something around 0.1 into 50 divided by 2 is 25 into root 3 is 1.7. So anyway, this value is 25 into 1.7. Let's say 25 into 2. Okay, even if we get 2, it will be 50 Newton. But multiplying by 1 will be only 5 Newton. Okay, so I've taken as 2, but the value is 1.7. Okay, therefore actually this Fs is less than 5 Newton, right? So Fs is actually less than 5 Newton. Okay. So if I consider initially the system is at rest, if I assume, then here in this side, this component is 15 to sine 30 is 25 Newton. And here the tension, here the weight is 1 Newton. So the tension is, if we assume 1 Newton, so here it will be 1 Newton, 25 minus 1, so it is 24. So therefore external force is bigger than the net resultant force. If R is the resultant force acting on this is greater than Fs. Okay, so actually you should be able to understand with in a very short time. You have to you don't spend much time for that. Okay, by the way, in exams they won't give this newness value. They straight away ask you what is find the acceleration. Then you no need to bother, just you can apply F equals ma and find. Okay, but if in case if they given you a question like that, then you have to do according. You have to first check whether the applied force is greater than the maximum friction force or not. The resultant force acting on the object is greater than or not. So, but here we can see the maximum force acting on the object is greater than the maximum friction force. Therefore, it will accelerate. Okay. Okay. So if one day if you are explaining to your friends or a set of students, this is the way you have to explain, right? You have to give the complete explanation, right? Okay, then only it will be clear. Okay. Anyway, so then we know now the system will accelerate. Therefore, now I can find the acceleration. For that, we have to use Newton's second law. Okay. So first I consider this 0.1 kilogram and applying F equals ma or Newton's second law to 0.1 kilogram mass. Okay, so in the upward direction, so here T minus weight is 1 Newton. T minus 1 equals mass is 0.1 into A. Okay, so this is equation number 1. and then I can apply F equals MA lying F equals MA to 5 kilogram in this direction. Angle 30 with the horizontal. Okay, so it is 50 sine 30 minus T equals mass is 5 into A, equation number 2. Sorry, here we want to write we have to include the friction. Okay, so the first thing you have to identify the direction of the friction. Okay, since the object is now moving downward down the plane, the friction is x in this direction. So here's the friction. So the friction here Fk, because kinetic friction. So then now you have to find the kinetic friction. So I'll find Fk is equals to 0.05 nu k into r. R is 50 cos 30. So 50 into cos 30 is root 3 over 2. So then we have Fk equals 0.05 into 25 into root 3. Okay, so let's find this value. So first root 3, square root of 3 is 1.732. Let's take as 1.73. So 1.73 multiplied by 25 multiplied by 0.05 is equals to 2.16. Okay, 2.16. So this is equals to 2.16 Newton. Okay, so then I can apply F equals MA, lying F equals MA to 5 kilogram mass in this direction. So in downward we have 50 sine 30 minus the tension T minus the friction is 2.16 Newton is equals to mass times mass is 5 into acceleration A. So 50 sine 30 is 25 minus P minus 2.16 equals to 5A. So I take this as equation number 2. So we have 1 plus 2. Here 25 minus 2.16 is 25 minus 2.16. So it will be 22.8. Yeah, get these two, then you get 25. Okay, so it will be 22.84. So we keep in first decimal place. Okay, that's fine. 22.84 will be here. Minus 1 is equals to. So I add equation 1 and 2. So plus t and minus t cancel. And here subtract 1 equals 5a and 0.1a, 5.1a. Therefore, a equals to 21.84 divided by 5.1. Okay. 21.84 minus divided by 5.1, 4.28. So we can take approximately 4.3 is equals to 4.3 meters per second squared. So that is the acceleration. Okay. So then you can mention the acceleration of A is in this direction, 4.3 meters per second squared, and the acceleration of 5 kilogram is 4.3 meters per second squared in this direction. Okay, so this is for 5 kilogram. Acceleration of 5 kilogram is for this one. The direction is this, you have to indicate the direction. Okay. And then you can substitute the value of A in equation 1 to find the T. So therefore tension T is equals to T equals 0.1 into A is 4.3. Minus 1 goes to the other side, so plus 1. So therefore T equals 4.3 plus 1, T equals 5.3 Newton. 0.1 into 4.3. Zero point four three plus 1, so 1.43 newtons. Okay. So that is the tension. Okay, any questions? Take a screenshot and write. Let me know if you finish writing, so then we can move on to the next question. Okay. Then I'll erase this. Okay, the next question. Question number 3. Okay, so we have a mass of 4 kilogram on a rough plane. The angle I'll mark the angle as theta variable. The nu s is equals to 0.6. Okay, and the question is, find the maximum value of theta find the maximum value that theta can take yeah, let's say initially object is stationary on the inclined plane, stationary on the inclined plane. Okay, and then find the maximum value that theta can take without disturbing the equilibrium. Without disturbing the equilibrium. The object. Okay. So initially object is at stationary on the inclined plane. So you want to find the maximum value of theta without disturbing the equilibrium. That means now, for example, you can see this one is on this inclined plane. So now it's making an angle, right? And when I increase the theta, so after a maximum value, what will happen? It will disturb, and then the equilibrium breaks and it will slide down. So you want to find the maximum value of theta without without breaking the equilibrium. Okay. Okay. So do it soon. I'll give you a couple of minutes. Theta is the angle. Yeah, this angle I have marked. The inclined angle. Angle of inclination. Angle of inclination of the uh, plane. So the question is, you have to find the maximum value of theta. Theta is variable, right? You have to find the maximum value of theta without breaking the equilibrium. It's a small question. If you did this type of question once, then you can do it easy actually. Okay, so here the mass is 4 kilogram, therefore weight will be 40 Newton. And I can resolve this weight into two perpendicular components. One is in this direction and the other one is in this direction parallel to the plane. Okay, so here this component is 40 cos theta in the units of Newton, and this is 40 sin theta in the units of Newton. Okay, so then I can consider the equilibrium. Okay, so considering the, because initially the object is in equilibrium, right? Considering the equilibrium of the object, considering the equilibrium of the object. Okay, so first I consider perpendicular to the plane, so in this direction. So in this direction, making angle theta with the vertical. Okay, so this angle theta means this angle 90 minus theta, this is 90 minus theta, therefore this angle is theta, therefore if we draw a vertical line, this angle will be theta. Okay, so I'll draw nicely here. So in this angle theta, so in this direction we have I have considered this direction, so in that direction we have r. Okay, I got an answer from a student as 31 degrees. Let's see. So here r equals to, so r is in this direction, but this component is opposite to that, minus 40 cos theta. So since it's equilibrium, net force has to be 0. The resultant force has to be 0. Therefore r equals 40 cos 30. So 40 cos 30 means r equals 40 into root 3 over 2. So I can write 20 root 3 Newton. So that is the value of r. And then I can consider the direction parallel to the plane. So this angle theta, and this direction we have f. Okay, f. So f equal f minus uh, 40 sine theta. Sorry, sir. So here we are. Sorry. It's cos 30, not cos theta, not 30. So 40 cos 30. Therefore, R equals 40 cos 30, cos theta. Sorry, guys. Sorry for that. Okay. Here, because the angle is theta, this is 40 cos theta. Okay. So therefore, if you take this to the other side, it is R equals 40 cos theta. So here then, if in this downward direction 40 sine theta, if is in this direction, the plus f minus 40 sine theta equals to 0. Since the object is equilibrium, so according to Newton's first law, the net force has to be 0. The object is at rest means there is no any unbalanced force. The forces are balanced. So therefore, F equals to 40 sine theta. Okay. So yeah. Okay. And then I take this as equation number 1 and this is as equation number 2. So, and I'm going to divide equation 2 by 1. So F over R is equals to 40 cos theta divided by 40 sin theta. So 40 and 40 cancel. Hold on. Sorry, it should be sin theta divided by cos theta. Because I divide equation number 2 by 1. In 2 we have 40 sin theta. And then in 1, 40 cos theta. Okay, now it's me. So 40 and 40 cancel. Therefore, we get F over R is equals to sin theta divided by cos theta tan theta. Therefore, F equals R tan theta. Okay, F equals R tan theta. Okay. And here we know that the friction force is always less than or equal to Fs, right? It's very important. But now we want to find the maximum value of the angle. Okay, before explaining that, I will write this part also. So here, F is equals to R tan theta is less than Fs. We can write, we know Fs is equals to nu s times R. So therefore nu s times R. So R and R cancel because you can divide R is not equal to 0. Definitely there is a content. So therefore tan theta is less than or equal to nu s. Okay. So now what we have got here is actually if the object is in equilibrium, the condition for the object to be in equilibrium, because we obtained everything by considering that object is in equilibrium. So if the object is in equilibrium, tan theta should be less than or equal to nu s. So the value of the tan theta should be less than or equal to nu s. Okay. Therefore, the maximum tan theta value is equals to nu s. Therefore, tan theta, this maximum is equals to nu s. Okay. So therefore, we know tan theta will be maximum when theta is maximum. Therefore, tan theta max is equals to nu s is how much? 0.6. So therefore, theta maximum, the maximum value of theta is equals to, if you take the tan to the other side, it becomes tan inverse 0.6. So you can find this using trigonometric table. Can you find and let me know what is tan inverse of 0.6? Now, for example, tan inverse of 1 over root 2 is equals to 45 degrees, because tan 45 is 1 over root 2. Therefore, if you find the inverse value of 1 over root 2, that means you take 1 divided by root 2, 1.414, then you get a number. No? So if you take the inverse value of that, you get 45 degrees. So likewise, you have to tell me what is the inverse value of 0.6. I don't have a trigonometric table right now. Maybe I can take grade 11 textbook, or it might have, no? Okay, yeah. So, which, okay, so natural science, non-natural tangents. Tangent 0.6. So here 0.6 is 30 degrees. We have 5969, 10 minutes, and then for another 31 needed. The 31 is H. So plus H. So 30 degrees and 18 minutes. So that's the angle. So here we want 0.60. So yeah, 30 degrees and 18 angle. Okay, I'll check. Did you send me in through WhatsApp?
Yes, sir.
Okay. Mm-hmm. S equals mu is R. So you have found the Fs value. R equals 40 plus 30. Okay, so you are actually considered in the you have considered in the that maximum angle, at the maximum angle. So at the maximum angle, now we know, we write F is less than or equal to Fs. So I have written this, I have done this question considering a friction has a value less than Fs. Okay, So according to his working, he has considered this F is equals to Fs. So then straight away you get the value, but I think only the angle, yeah, so it's correct. So 3 over 5 is actually 6 over 10, no, 0.6. Yeah. So what I did is I consider a general case, and then I logically say that this is equals to this, the maximum value should be this. But here in this method, it has straight away considered the limiting condition. That means the maximum angle. So at that condition, so we can consider that the friction force is equals to Fs. So that Fs we can take here, and from that way also can do. Okay. So your method is also correct. Okay. Okay. Did you all understand? Anyone has any questions about this? Okay, good. So Abhishani also has done by considering that maximum case equation. Okay, good. Okay. So I think we are good with inclined planes. By the way, I request you to do like past paper questions. Yeah, Abhishani, your method is correct. He also has done by considering the maximum situation, right? F max equal 40 sine theta nu SR. Okay. Uh, yeah, yeah, correct. Anyway, I recommend you to write this method also. Okay. In this way also you should write. Okay. As the friction force is always less than or equal to Fs. Therefore, if SR tan theta is less than or equal to nu SR, tan theta is always less than or equal to nu S. Okay, so the maximum at the maximum angle tan theta will be maximum, that is equals to nu S. Okay, so therefore theta max we can find that will be 30 degrees and 18 arc. About 30 degree and 18 minutes. Degrees, minute, arc, minute, yeah. Okay. Okay, guys, so we'll try to do one more question from this, and I'll try to send you past paper questions or the questions related to inclined planes, and you should do, I mean, don't wait until I give a question. You have to find out some questions, and you have to try. Okay. And if there's anything you want to be, you feel like you need explanation, please send it to send it to me. Okay, so that I will share that question in the group so that everyone can try that question. Because if a question is if someone finds difficult, so it better we discuss that question. So I can give the opportunity to others also to do that question, and then in the upcoming class we can discuss. That is very important. So if a student is sending me a question, means it makes me really happy. That means I can understand. Okay, this guy is doing some work, doing some. And by the way, Hirosh, you had some questions on that day, right? You wanted to. Yeah, yeah. Can you send me now? Would be great help. If you can send it to through the Zoom chat to TKI, so it can be easily viewed by here. Otherwise, you can send it through WhatsApp. So probably in the next class, we will start the momentum. Okay, then you can send it through WhatsApp. Yeah, it's okay. So make sure to do a lot of questions as much as possible. That's very important. Did you send? So do you want to discuss question number 34 and 35? Okay, the 33 is seemingly too big. I will first do the 34 because we have only another 20 minutes. Okay, so let's do the question number 34 first. Okay, a body placed. Okay, by the way, I think for Zufar, I did something with kinematics, right? Equation from motion. But for Abhishani, you haven't done, I think, the kinematics. But anyway, don't worry. I'll try to explain this in a way that I can understand. Okay, so here a body placed at the foot of a smooth, long plane inclined at an angle of 30 degrees to the horizontal is projected along the plane with a velocity of 10 meters per second upward. Okay. Find the distance along the plane the body would move and the time it would take to move this distance. Find also velocity with the body would again return to the foot of the plane. Okay, so let's draw the inclined plane first. So here's the inclined plane. Um, so angle is 30 degrees. So the angle is 30 degrees, is projected along the plane with a velocity of 10 meters per second upward. So at the foot, so the particle is here initially, and then it is projected along the plane. So in this direction with a velocity of 10 meters per second. 10 meters per second upwards. Find the distance along the plane the body would move and the time it would take to move this distance. Okay, so what happens now? The particle has projected upward, no? So anyway, it's moving upward means deceleration because the gravity always pulls downward. So what happens? The velocity decreases, and as it goes upward up the plane, the velocity decreases at a maximum distance traveled. The velocity becomes zero. V equals zero. So and then it will again fall or move down the plane with uh, some acceleration. Okay. So when it's moved upward, it has a deceleration, and then when it's moved downward, it has acceleration. But the magnitude of this deceleration and acceleration will be same. Okay. Okay. In upward motion, there is a deceleration, and downward motion, there is a acceleration because throughout the motion, there is acceleration in this direction. Okay. The acceleration of the object throughout the motion will be in this direction. A. Okay. Uh, Find the distance along the plane the body would move and time it would take to move this distance. So we want to find the time. Let's say here the time is t equals 0. So when t equals 0 started the motion. That means when it's projected at the foot, the stopwatch is started, and when it comes to here, the stopwatch stops, and then the time reading is capital T. So we want to find that time and also the distance that has moved from here to here, this distance. Let's say that as uh, h. Let's take it as h or x. Better go with x. Okay. Find also the velocity with the body would again return to the foot of the plane. Okay, so again it will fall downwards, and when it comes here, we want to find the velocity. First, we will find the x and t value. Okay, so I will do this question in two methods. Okay, so first method one. Okay, so the method one. Here first I mark the gravitational acceleration is always vertically downward g, which is 10 meters per second square. Okay, so here first I'm going to consider the first method is now the g is vertically downward, right? Okay, I put that here. Vertically downward, g equals 10 meters per second square. So this angle is 30. Okay, so I'm going to resolve this g in two perpendicular directions. I'm going to resolve this g into two perpendicular directions. One is along the plane and one is perpendicular to the plane. Okay, one is along the plane, one is perpendicular to the plane. So g is a vector. We know vectors can be resolved. Okay, so here then this component is 10 cos 30 because this angle is 30 means this angle also will be 30 degrees. So this 10 cos 30, this 10 sine 30. So now the first method, in the first method, I'm going to consider the motion of the particle along the plane. Okay, so I'm going to consider the motion of the particle along the plane. So which is making 30 degrees with the horizontal. So in that direction, I'm going to use v squared is equals to u squared plus 2as. Okay, v means the final velocity at the maximum height, at the maximum distance, velocity will be 0. Okay, so okay, I'll finish this and then I'll do the next question. So here v squared in this equation of motion, v is the final velocity, u initial velocity, a acceleration is displacement. So at the maximum height, when it comes over the maximum height, the velocity will be 0. So the final velocity is 0, initial velocity is 10. So 10 squared plus 2 into, so I'm using this equation in this direction. Now I have resolved the vector g into two perpendicular components. So one is this one and the other one is this, but this one is parallel to we are considering, and also it is opposite, but this component it's perpendicular to the direction that we have considered, so therefore this component does not make any effect in the motion along the plane. Okay, it doesn't make any effect in the motion along the plane, but only this component will be the make is to cancel, minus 10x takes to the side, plus 10x equals to 10 into 10, 10 squared. So this 10 and this 10 cancel, so x equals 10 meter. So once I got the value of x, now I can find the time. Also, we can find the time using this formula, v equals u plus at. Okay, so again in the same direction. So the method one, I'm considering the along the plane direction. So here again final velocity is 0, u is 10, and acceleration is downward, 10 sine 30. So 10 into sine 30 half into capital T. So therefore 5t equals 10. Therefore t equals 2 seconds. T equals 2 seconds. Okay. So that is okay. That's the method one. Or else you can use to find the time, s equals u plus v over 2 into t. So because here 10, u is 10 plus v is 0 divided by 2 into t. So then again we get t as 2 seconds. Okay, and then method 2 is I will be considering vertical upward direction, vertical direction. Okay, so if I'm considering the vertical direction, I need everything to be in vertical direction.